Hello, Assalamualaikum everyone. Today we from Group 2 of Class 4A will be presenting our topic entitled Sequential Excavation Method or SEM. This presentation is prepared for Madam Farah Nuriza Muhammad Yusof as part of the course CMA544 Civil Works Construction under the Faculty of Built Environment University Teknologi Maharaja Alam. And this presentation is prepared by me, Mimi Arsa binti Adnan, and Adrina Nazra binti Adnan, Anissa binti Ashraf, and Siti Nur Azila binti Abu Zaki. So our focus today will be on the use of SEM in the Niayesh Urban Tunnel Project in Tehran, Iran, which is the one of the largest urban tunneling project in the Middle East. So this is the content that we will be present, which is background structure and project detail, main method used in construction, issue and challenges, inclusion of advanced technology to the structure built in protecting the environment, conclusion and our references. So let's move to project overview and objective, which is about Niayesh Urban Road Tunnel, located in Tehran, Iran, and the start of the construction, which is at 26th of March 2011, and completion of main tunnel works done by 19 March 2012, which is with excavation completed, and official opening by 17 February 2013, project duration around 1 year in 11 months, and tunnel length approximately at 2.3 kilometers. Tunnel type, which is large span urban tunnel, is soft ground, and the method that used is sequential excavation method, SEM, obviously, with side wall drift SD and central diaphragm CT techniques. So the main objective was to minimize surface settlement in urban area while using a suitable excavation method. The SEM technique, along with side drift SD and central diaphragm CT, was selected and optimized through 3D finite element modeling. So let's move to the background of the structure Niayesh Urban Tunnel Tehran, Iran. So for the definition, the Niayesh Tunnel was designed to connect two major highways in Tehran, which is Niayesh and Sad, in order to reduce urban traffic congestion. It is considered one of the largest urban tunneling projects in the Middle East. And the tunnel design features a unique mouth-like shape that supports 3.5 traffic lanes with a width of 18 meters and a height of 10.9 meters. Due to its shallow depth, the tunnel poses a high risk of surface settlement. The tunnel passes through Tehran alluvium, which includes sandy gravels, silts, clays, and a fill material, all of which influenced by the excavation and support from system design.
So I'm going to explain the method used in construction for this project. This method has 5 phases, which for the phase 1 are site investigation and pre-excavation. Phase 2 is sequential excavation method. Phase 3 is support installation. Phase 4 is optimization. And the last one is finalizing and post-excavation. So as the usual for the first step in every construction method, we must do the site investigation. And next for this particular project, they use site drift SD for the selection of excavation method due to lower settlement. Then numerical modeling is just how this stimulates SEM step by step by using Plexus 3D, which they want to predict and analyze how the soil and rock will behave during the construction. For the phase 2, which is sequential excavation method, firstly they subdivide the tunnel phase. Okay, as you can see the image here, some of them got 5 segments and some of them got 7 segments. 7 segments actually to reduce the stress concentration. So they will start to excavate for each segment separately and step by step until complete full ring closure with final lining. Phase 3 support installation. So first, as the excavate begins, they must install the support to prevent the instability. Next, the monitoring and validation actually to confirm the ground behavior matches with the prediction from numerical modeling that we have been through in phase 1. Phase 4 optimization. Trailing distance adjustment is the process of modifying of this distance during excavation to optimize tunnel stability, safety, and construction efficiency. Too long may higher the risk to collapse, and too short might needed higher cost and effort. In the last phase, they did the permanent lining installation, which to provide long-term structural stability and durability. And next is the system integration and commissioning. So in this phase, all systems were tested to ensure the tunnel is fully functional, safe, and ready to be used, and to reduce the risk of system failure. Thank you.
The issue during site investigation is soil condition. Along the tunnel alignment, it's revealed complex soil condition through Tehran alluvium, which consisting of sandy gravel, silty clay, and mixed fill. The variability in cohesion and cementation raise concern for settlement and structural stability as shown in the table. Findings include formation like Hazardara with over 1,000 meters of cemented gravel, crucial for long-term support, and recent alluvium, just 10 meters thick but highly influential due to its uncemented profile. This detail directly impacts support design and excavation sequencing under the SEM method. Next, as tunneling progresses, excavation causes stress redistribution in surrounding soil layers. Ground movements start gradually about 4 tunnel diameters ahead of the face, which often unnoticed but critical. Peak settlement occurs 2 diameters behind the tunnel face, beyond which deformation level off. This makes timely monitoring essential. Using strategic placement of settlement points and predictive analysis, engineers can anticipate and mitigate structural risks throughout the excavation cycle. Post-construction monitoring revealed a gap between simulation prediction and actual field data. While the 3D FEM estimated about 44 of settlement, field measurement near 6-story structure showed just about 27 millimeters. This discrepancy required calibration of instrument and reassessment of model assumption. Continuous observation, especially in shallow overburden zone, became essential to ensure structural safety and address soil variability. This finding underscored the importance of integrating field feedback into predictive modeling.
And also in sustainable tunneling, real-time geotechnical monitoring with the IoT sensor help track ground movement and pore pressure, which allowing early detection of the risk like settlement or sinkhole, and this protecting their nearby structure and ecosystem. And this is a very eco-friendly fiber. It involves shotcrete offers strong and durable support while cutting CO2 emissions and void waste. And with the robotic shotcrete and dust suppression, we ensure precise application, safer condition and cleaner air, especially vital in the dense urban environment like Singapore and Tehran. So together, these innovations make tunneling smarter, safer and greener. So in modern tunneling, adapting the sustainable technologies is very crucial for their environmental protection, such as energy efficiency, low emission machinery, reduces their fossil fuel consumption, and to cut CO2 emissions and minimize the noises, especially in the urban or protected area. So we have here the ground freezing with the eco-safe refrigerant to strengthen the soil safely and avoid groundwater contamination, and unlike the chemical grouting. And building information modeling, or we call it as BIM, allow the engineer to simulate their plane and optimize their each pace, reducing the material loss, over excavation and ecology impact. These methods are shaping the future of the green tunnel construction.
So finally, we have come to the conclusion. The Nyayish Tunnel project demonstrates how the sequential excavation method (SEM) works effectively in soft ground conditions. The tunnel's shallow depth and large span require SEM to minimize ground settlement while preserving settability throughout the construction process. And the side drift method, together with a planned excavation sequence and a 15-meter trailing distance, proved to be the safest and the most efficient approach. And the project demonstrates that successful urban tunneling depends on the proper planning and modeling and method selection. Last but not least, this is our references that we use for this assignment. So I think that's all from us. Thank you very much for your time and have a good day.